Okay, so here we're going to take a look at an implication, all right, or sometimes known as a conditional. So here we have logically written an implication. So if P then Q, or P implies Q, right? So where P and Q are both statements, right? So P is a hypothesis, is the hypothesis, when written like this. Sometimes it's called the antecedent. Q is the conclusion, sometimes called the consequent. So so this is definition, right? So here when we say this is by definition, this is what it means to be logically correct. Implication is true provided P is false or Q is true or both, and false otherwise, right? So here is where we'll introduce our truth table. So you have statements P and Q, and then the implication if P then Q. All right, so by definition, right, this states that, so the most basic one, if they're both true, all right, then the implication is true. All right, so then here it says, all right, so Q is true, but they say this is false. All right, then that is also true by definition. All right, again, think of the hypothesis as the promise. All right, so if the promise happens, then the implication must happen as well. In all other cases, right, so let's say here, so the other one would be false, and then again in this case, right, the promise wasn't kept, so just by definition, the implication, right, whether that's true or false doesn't matter, so this implication is also true. All right, now the only case where it is false here, this false otherwise, would be where the promise, the hypothesis is true, right? The promise, right, is made, right? But then the result of that was not achieved. It was false. Then that would make the implication false. Okay? So this is our truth table for the implication, right? So we're going to spend some time just kind of convincing ourselves that this is going to be true. Okay, now as a kind of get us started here, let's take a look at this statement. All right, so if Tommy doesn't eat his broccoli, then he will not get any ice cream. So I want to know which are equivalent. Okay, all right, so now again here, this promise here, if he doesn't eat his ice cream, then he will not get any ice cream. Okay? All right, so if Tommy does eat his broccoli, I forgot a word there, then he will get ice cream. Now this actually is not logically equivalent. Right? Our promise here is when he does not eat his broccoli. There is no implications here of when he does eat his broccoli, so not equivalent. All right. Now, how about this one? If Tommy gets his ice cream, then he ate his broccoli. All right. Now, as it turns out, this one is logically equivalent. All right. The promise here, right, as it turns out, this is what's known as a contrapositive, which we'll talk more, where we negate the conclusion, right? This was he will not get any, so actually got ice cream. So the implication is that he did, in fact, eat his broccoli. So if the promise is he got ice cream, then he ate his broccoli. That is true, right? So these are equivalent, logically. All right. Now, if Tommy doesn't get his ice cream, that's the promise, he doesn't get any ice cream, then he didn't eat his broccoli. And again, no, that's not logically equivalent because the first one here is focusing on the promises that he doesn't eat his broccoli. All right, not about getting ice cream. Okay. So here, he might not have gotten ice cream, that promise might have been kept, but it could have been for other reasons. All right, so this also not equivalent. And then Tommy ate all his broccoli and still didn't get any ice cream. All right, now for this one, this is one specific situation, right? It's not an implication. It's more of this happened and also this happened, right? So it doesn't encapsulate, right, what would happen in all situations when he does not eat his broccoli, right? So this here is also not logically equivalent, right? So the only one logically equivalent here is this, right? Where in this case, the promise is that he got ice cream, right? So that means that he ate all his broccoli. Okay. All right. Let's go over one more example to kind of get us convinced that this truth table is what it is for an implication. All right. So let's say if you earn an A on the final exam, then you receive an A in the class. Excuse me. Okay, so again, let's break it down into its atomic statements, right? So P would be the statement that you earn an A on the final. And then Q, you receive an A in the class. All right. So now let's take a look at the truth table for this. Okay. So you earn an A on the final. So let's say that is true. And then that is true. All right. So the statement is true. That's the implication. Right? So that would be the outcome where you did earn an A and then you received an A on the class, right? Okay, so now let's take a look at what would make this implication false, right? What does that mean in terms of my statements? All right, so let's take a look here. Let's say that this is true. And then this is false, right? So here what we're saying is that you did earn an A on the final, but you did not earn an A in the class, right? That would be that the instructor was lying, right? So the implication was false, right? Okay, so here the promise was broken, so the implication was false, right? So now let's look at the third case. All right. Okay. So here we have you did not earn an A on the final and you did not earn an A in the class. All right. That's what this P would be false and Q would be false. In which case the promise was not broken. All right. If I promised you an A on the final or the instructor promised you an A on the semester on the final, if you get an A on the final, then you would get an A in the class. All right. That implication is still true. All right. Was not called, not determined to be lying in that case. All right, now also for the other one, let's say that the last case here, false and true. So let's say you did not get an A on the final. And you received an A in the class, right? Again, still not a liar, because you could have been in a situation where there was, maybe you were really close to an A on the final, and that still got you an A in the class. Right, so my initial statement, implication, has not been proven false. Right, my promise was not broken. So in general, that implication is still true. Right, it doesn't fall for this situation, so just logically, that implication is still valid. Okay, so that is how the truth table for an implication. We'll look at some other relationships here between P and Q next.